Okay, so we're going to try it like this and see if we like this better than we do before. So we're going to watch 8.1 today and then 8.2 tomorrow, and then you're going to let me know which one you like better. Okay. We're going to talk about simplifying rational expressions. And you need to know that rational means fraction. Whenever they use the word rational, they're not trying to say that it makes sense or that it's logical. They're trying to say that it looks like a fraction. That's what this whole chapter is about. By the end of it, you will hate fractions more than you do now, but you'll be a lot better at them. You can't have a 0 on the bottom of a fraction. That's because it will cause the fraction to become undefined. And we can't have undefined fractions. Undefined means it's unlawful, not allowed, bad stuff. So, these are some of the problems that we're going to start out with. Get rid of that. So you'll need to know what exactly makes these statements undefined. And we said that if it was undefined, it meant that it had a 0 in the bottom of the fraction. So the only way to find out what will cause these statements to be undefined is to set the bottom of the fraction equal to 0. So in this case, that would mean x is equal to 0. That's the only value for x that will make this statement undefined. Here, we set the bottom of that fraction equal to 0. Then you have to solve for x to find out what values of x will become undefined. So, if I subtract 1 from both sides, you get when x is equal to -1. If x were equal to -1, then I'd have -1 plus 1 on the bottom. -1 plus 1 is really 0, which makes my expression undefined. Over here, I'd have x squared minus 4 equals 0. In order for me to solve this, we found out in the last chapter, you have to factor it first. So that's x plus 2, x minus 2. Then you have to set each of these equal to 0, because we know one of them has to be 0. Then I solve each of these. So minus 2 and minus 2. When x is equal to -2, plus 2, plus 2, when x is equal to a positive 2. These are the two values of x that make that equation equal to 0. Just to show you what I mean, if I were to take the -2 and plug it in up here for x, -2 squared is -2 times -2, which gives me a positive 4, and 4 minus 4 gives me a 0 on the bottom, and we can't have that. For this one over here, you set the bottom equal to 0, just like before. Which means we're going to have to factor because of the square term. X and x, two things that multiply to give you 15 and add to give you 8. 3 and 5. So that means that x plus 3 is equal to 0, or x plus 5 is equal to 0. So x equal to -3 or x equal to -5 are the two values that x cannot be, because it would make that bottom equal to 0, and we can't have the bottom equal to 0. Okay, so we took care of that part. Now let's get to some real problems. There are some basic steps to simplifying rational expressions. That is finding out the expression that makes it equal to 0. We didn't simplify anything over there. There are some basic steps to simplifying rational expressions. You need to factor the top and bottom of the fraction, and then cancel out the factors that are on the top and on the bottom. It has to be on both, on top and on bottom, in order for you to cancel it. Now, you've been doing this forever. You just didn't call it that. You called it something else. And we're going to push it a little bit further now that we have that whole factoring skill in our toolbox. So this is our expression. We're supposed to factor the top and factor the bottom. So when I go to factor the top, that means finding the prime factorization of the top. So the prime factorization of 12, if I were to break it down, would be 2 times 2 times 3, and then I have an x. Prime factorization of 42, if I were to break it down, would be 2 times 3 times 7, and then I have 2 x's. And the rule is, if you have it on top and on bottom, then you can cancel it out. So my 2's can cancel each other out, my 3's can cancel each other out, and a set of x's can cancel each other out. That leaves me with a 2 on top from that one and a 7x on the bottom. That is my simplified expression. Now that I've simplified it, they want me to go back and say, what is it that x can't be? Or state the restrictions, that's the word they use. So that means I'm saying the bottom is equal to 0 and finding out what x can't be. I know over here we said x is equal to 0, x is equal to -2. Well, that's what it is that makes it undefined. That's finding what's undefined. Stating the restrictions is saying what x can't be, because if x were that, then it would be undefined. It's a different way of saying it, but it's basically doing the same thing. It's just how you write your answer is different. So, for this, when we're stating the restrictions for x, that means I say 7x has to equal 0. That means x is equal to 0. But x can't be equal to, that's the one thing that x can't be. That's what we found out, what x can't be. That's what we found over there, what makes it undefined, and it cannot be undefined. So since this is what x can't be, I want you to go ahead and put a line through it. Now, I don't know if your book does that or not. Your book may say x can't be 0, but I'm okay with you saying x is not equal to 0. That's the simplified answer. This is the restriction. Let's look at another one. Whoops. That probably looks familiar. First, we have to factor the top and the bottom. That hasn't changed. I can't factor the top. It's already factored. There is no GCF. There are only 2 terms. It's not the difference of 2 squares. It's done. Top is done. It's its own factor. The bottom, however, can be factored. Now the rule is, if you have it on top and on bottom, then you can mark it out. Do I have something on top that is a factor with something on the bottom? Sure. I have this whole x plus 3 up here, and this whole x plus 3. So I can mark them out. That leaves me with a 1 on top and an x plus 5 on the bottom. And this is my simplified answer. For my restrictions, I'm supposed to set the bottom equal to 0, right? Well, if I set this equal to 0, that's going to give me one of the restrictions, but we just did this problem before and we found 2 restrictions. So the question is, do we have to use that one that we marked out as a restriction too? And yes, you do. Your restrictions come from the original problem. They do not come from your answer. So you have to set this bottom equal to 0. Now, over here when we were doing it, if I set this bottom equal to 0, we get the same answer out. X can't be 0. But over here, since we have marked something like an x out on the bottom, we needed to go ahead and take care of that. So I'm going to go ahead and set this one equal to 0. Which means each individual one has to be equal to 0. So once again, since we're talking about the word restrictions, we have to go through and put our knots in. So x is not equal to negative 5, and x cannot be equal to negative 3. That's our restriction. Always find your restrictions from the problem, not from the answer. Let's try another one. Go ahead and pause it and try that one yourself. Okay? So when I factor the top out, 2 days and multiply to give me 8 and subtract to give me 2, or 4 and 2. My 4 has to be the plus, so my 2 is the minus. Factor in the bottom out, x plus 2, x minus 2. Then I have to go through and cancel out the stuff that's the same on top and on bottom, which leaves me with x plus 4 over x plus 2. Now the question is, can I cancel out the x's? I mean, I got an x on top and an x on bottom, right? That's the rule, something on top, something on the bottom. The problem is, this is not a factor. I know that because in order for it to be a factor, it has to be multiplied by something. Back over there, when I said x plus 3 was already factored, it's its own factor. That's because I was talking about the whole x plus 3. Together, that's one factor. Here, x plus 4 together is one factor. You can't separate out these x's and mark them out. You can't even say that this will factor down into an x plus 2 and an x plus 2, and then we can cancel stuff out. Can't do that because that's not how that factors. So, this is the answer. That is your simplified answer. Then going back to find the restrictions, set the bottom equal to 0 since I already have it factored. I'm just going to go from that. That would mean x plus 2 is equal to 0. Well, technically not. And x minus 2 is not equal to 0. So x is not equal to negative 2, and x cannot be equal to positive 2. This is what is true. That's what can't be. That's why you put the little not sign in there, so they know that it's not those things. 2 more. Go ahead and pause it and try those two. Let's see how you do. Okay, I hope you factored them correctly. So I'm hoping you took a 3 out of the top. The bottom doesn't factor. Now we're supposed to mark out things that are the same on top and on bottom. Do we have anything that's the same on top and on bottom? We do. I know that this says x plus 4 and this says 4 plus x, but you learned ages ago that addition had the commutative property, so we could rearrange those things. So instead of me writing the bottom as 4 plus x, I can write x plus 4, because it can get rewritten because it's addition. So now I can cancel those out, which just leaves my answer as 3. Over here, when I go to factor stuff out, take a 3 out, and I'm left with x plus 4. Down here, I have 4 minus x. Are they the same thing? Well, if I rearrange it, I can rewrite it so that it says 3x plus 4 and then negative x plus 4. But I can't take that negative out. I can't separate it out, because if I do, we learned when we were factoring that if I take that negative away, I also have to take a negative from there away, which would make that a minus 4 instead. So I could have 3 times x plus 4 over a negative x minus 4, but then they're not the same either. So we can't cancel anything out. And since we can't cancel anything out here or here, that is your simplified answer. In fact, if you wanted to, you could say that was your simplified answer, because there's nothing else to do to it. However, we still have to find the restrictions. So for my restrictions here, in order to find out what x can't be, I set the bottom equal to 0. And we get that x cannot equal negative 4. For my restrictions over here, to find out what x can't be, I set the bottom equal to 0. And I solve. And I get that x cannot equal positive 4. But since there were 2 different problems, that's all okay. Let's talk homework and classwork. I didn't write any down. No, you do not get off that easy. I did write a ton of notes. I'm looking on page 318. Practice exercises. Numbers 1 and 5. $11, $15, $25 and $31. Homework, same page. Numbers 3 and 7. 13, 17, 23, 27, and 33. And we'll call that it. There you go. That's not bad. I'll see you tomorrow when you have to decide whether you like this better or what we do tomorrow better. Bye!